How were equations solved before formal algebraic notation? Imagine trying to solve a puzzle without the picture on the box to guide you. Before we had symbols and letters to representing unknowns, mathematicians used shapes, words, and clever tricks to find answers. Long ago, people from different civilizations approached equations in ways that seem very different from how we do today. They thought about unknowns as parts of shapes or distances, not just abstract numbers. For example, the Greeks would draw rectangles and other shapes to show relationships between quantities. If they wanted to find an unknown length, they would compare areas of different shapes to figure it out. This was a kind of geometric algebra, where shapes stood in for what we now write as equations. The Babylonians, who lived thousands of years ago, used procedural methods that are similar to what we now call inverse operations. They would add or subtract the same amount on both sides of a problem to keep things balanced. For instance, if they had a problem like, what number plus 5 equals 10, they would think about what to do to get the unknown alone. They would subtract 5 from both sides, just like we do today, but they did it with words and numbers instead of symbols. These steps were based on logical procedures that made sense at the time, even without the fancy notation we use now. In some cases, they described unknowns as parts of a problem rather than writing a letter like X. They would say, find the length of this side, or what is the area of this shape, and then use practical steps to solve it. The Chinese mathematicians, in their famous book called The 9 Chapters on the Mathematical Art, used methods similar to solving systems of equations. They would eliminate unknowns step by step, much like how we do with elimination today, but all in words and diagrams. Around the 3rd century of our era, a mathematician named Diophantus began to use symbols for unknowns. His symbols were not as simple or systematic as ours, but they marked a big shift. He reasoned about unknowns and their relationships using these symbols, solving polynomial equations through logical steps. Still, he did not have the full set of symbols and rules we now associate with algebra. Even without formal notation, the idea of inverse operations was understood. Mathematicians knew that to solve an equation, they needed to do the opposite of what was done to the unknown. If they multiplied, they divided. If they added, they subtracted. They used these ideas to find solutions to linear equations and even some polynomial problems. They relied on geometric reasoning, verbal descriptions, and procedural steps to work through the problems. So, before we had the symbols and rules we use today, solving equations was like solving a puzzle with shapes, words, and logical steps. These early methods laid the foundation for the algebraic techniques we now take for granted. They show us how clever and resourceful mathematicians have been throughout history, using whatever tools they had to find answers.